Let's see, here we go. Present my screen. I'm going to present my thing. All right, beautiful. Hello. Woo-woo. Moving myself down here so I'm not in the way. So today we are going to be solving rational equations. Sorry, I'm always like at weird angles when I'm writing on this thing. So solving rational equations. So if you need to, feel free to always interrupt me. So you can either talk on, like turn your speaker on, you can throw the chat on. I have the chat on my other computer. So I keep glancing up at it. So if you ever need me to slow down, you have a question about something we're doing specifically, please ask. So don't sit there confused. So our main goal today is just to kind of get a little bit more comfortable. So after vacay, it's not like a new thing, something we're like semi-familiar with, and we're not killing ourselves here. So let's start with this one. Once again, we only have 6 of them, so it's not going to be too bad. Not trying to torture you too much today. We're struggling into vacation here, but we'll make it. Okay, so I'll give you a second to write that down, but that's going to be our first rational equation we're solving. So once again, rational means we have those fractions. We're saying that looks like a big old pain in the butt, so we want to take care of the fractions as our first step. So when we were adding and subtracting, we were finding common denominators, and we actually want to do the same thing here. We want to find the common denominator first. So I always kind of just write it off to the side. So like over here, I'm just going to write, what is the common denominator if I were looking at all of these fractions? So this one's just over 1, right? So if we have an x minus 3, 1, and x minus 3, the common denominator is just x minus 3. Okay, so once you have the common denominator, you are going to multiply everything by that. So you've done that in the past when we've just had like regular fractions, like over 12, over 2, over 6. You just multiply everything by 12. It's the same idea. So you're going to find the common denominator first, and then you're going to multiply each individual fraction by the common denominator. So we're going to multiply each of these by x minus 3. So I kind of just line it up. I just like put it next to each numerator, times x minus 3, times x minus 3, times x minus 3. I'm actually going to put those in parentheses just to make it a little bit neater there, but that's fine. So every single term gets multiplied by x minus 3, and then you kind of just see what magic happens. So what's going to happen here is these x minus 3s are going to cancel out, and you're just going to be left with 6. Okay, and then we have plus. Here nothing cancels, right, because it was just over 1. So I'm just going to distribute this 9 in, and I'll get plus 9x minus 27. Then we have our equal sign. And then over here, the x minus 3's cancel. So that's why you kind of do that step to get rid of all those fractions so they're not as much of a pain in the butt. And when those cancel, you'll just be left with negative 3. So this is definitely a way more manageable equation to solve. So now we can actually go solve it. Main goal is being to isolate x. So I'm going to combine these like terms here. So I would get 9x minus 21 equals negative 3. I'm going to add 21 to both sides. 9x is going to equal 18. And then last but not least, I'll divide both sides by 9. Okay. Now for every single problem, you have to check it. So it's not like if you're solving an equation, you can like check it to make sure you're right. No, you have to check it. Sometimes when you solve something, since you are plugging back into fractions, it will make your denominator 0, which we don't want. So that's why you always have to check your answer, because sometimes if it doesn't work, we call that an extraneous solution. So it's just part of your solving. Once you've solved, you're not done. You have to check it. So you go back and plug it into the original equation. So in this case, for my check, I just kind of do it off to the side. A lot of times I just do it in my calculator. I just kind of throw it in. But we have 6 over, and then we would plug in that 2. So 2 minus 3 plus 9, right? So that was just 9 over 1, equals negative 3 over 2 minus 3. So your main goal is, does the left side equal the right side? So that gives me what, 6 over negative 1 plus 9. That would just be negative 6 plus 9, right, which is 3. Okay. And then figure out what the right side is. That would be negative 3 over negative 1. Also comes out to 3. And since these two things match, we know that this is the answer. Okay, so we would say that is the answer. I always kind of just like do a check to make sure it shows that I did check my answer and it does work in this equation. So for now, you don't need to worry about doing anything else, but always make sure you're checking your answer. We'll see in a few minutes, an extraneous solution will pop up, and you'll know it because when we check it, it won't make sense. So I'm just leaving that up for a second. I don't like to rush. I know it's hard depending on your writing situation at home and where you're set up. So I'll always try to give you a few extra seconds to write. But please let me know if you see any questions on number 1. Okay, I keep getting weird. Someone just send me a message. Or...
Mrs. Sherman?
Oh, what's up?
How do you know if like your check is like actually an extraneous solution or if you're just like messing up?
Oh, well, I guess you don't if you're just messing up. That means you just messed up. So we'll see what an extraneous solution looks like in a few minutes. But yeah, if you just did something wrong, yeah, it's just not going to work. But then it would just be wrong either way. So I guess there's no perfect way to check. Hope you did it right the first time is what I'm going to say. But we'll see what one looks like in a minute. All right, so I'm going to start 2. I don't know why. Hold on, I'm just doing this. Okay, sorry, just giving me weird little noises here. Okay, so here's number 2. Beep. Once again, sorry, I'm always at weird angles on this bad boy. All right, so here's the original. 2 over x plus 2 minus 1/2. Okay, that doesn't look bad. Equals negative 3/4. All right, so we have a nice little equation going on. Our main goal is, before we kind of start to do anything, we need to find the common denominator. So I always kind of just do that off to the side. I'm a labeler, so I like to label everything. Common denom. So I go through. I know in my common denominator, there's going to be an x plus 2. And then I have a 2 and a 4. So if those are just like regular constants, the common denominator between those two things would be 4, right? Because 2 could multiply by 2. So my common denominator is going to be 4x plus 2. So that, remember, everything kind of needs to be represented. So I need the x plus 2. And then between 2 and 4, their least common denominator is 4. So that's my common denominator for the whole thing. So once I found that, I'm going to go back and multiply everything by that. So I kind of line it up next to each numerator. So 4 times x plus 2, 4 times x plus 2, 4 times x plus 2. So sometimes it's kind of annoying to write it out a million times, but it always sets me up for success if I have it written out. So now our main goal is we should kind of be, fraction should be reducing and make our life easier. So the x plus 2's cancel. I'm left with 2 times 4, so that's going to give me 8. So that wasn't bad, and that's definitely looking way better. Just be careful. I was doing this out, and I was rushing, as usual, because that's like the story of my life. And just be careful with this negative. Remember, since this is a binomial here, it would go with both of those when you distribute it. Think of that as negative 4 or minus 4. So as I distribute this in, that would be minus 4x. And then minus 4 times 2 would give me negative. Oh my God, guys, I just messed up. I'm sorry. Mr. Sherman, you nutbag. I never reduced it. I can reduce 4 over 2. That reduces to 2. Sorry. So reduce first. Don't start distributing like a crazy person. Now I was so interested in that negative. I got sidetracked. Now distribute. I'm going to do negative 2 times x. That's negative. I'm going to get my handy dandy whiteout shtick. Oh my God, this thing's just like not working and being evil. Okay, so I'm sorry. That's negative 2x, not negative 4x. I knew in my head I did something wrong as I was doing that. And then once again, negative 2 times 2 is negative 4. Okay, that makes more sense. I knew when that minus 8 was there, it didn't make sense. So reduce first. And then over here we have equals. The 4's would cancel. But then I would distribute the negative 3 into the parentheses, and that would give me negative 3x minus 6. Okay, now we're set up. Combine like terms on the left. I mean, that would give me what? Negative 2x plus 4. I'm going to get my x's together. So it doesn't really matter which way you solve, but I'll move that 3x over. And then I'm going to subtract 4. And I get x equals -10. So I feel like once you set it up, once you get the one to actually solve, it's not bad. That was just a few steps. I'm not done yet. I'm never done yet, even though I feel like I'm done because I solved it. I need to check it. So you go back, you say, I'm going to plug -10 in for my x. -1/2 equals -3/4. I'm going to be honest, I do most of this right in my calculator because I don't like some of these come out to weird fractions, which is totally fine. It's just you need to make sure that the left side equals the right side. So I'm grabbing the calc. I know that -10 plus 2 in that denominator is -8. So I'm just grabbing my calculator and I'll do 2 over -8 minus 1/2. Oops. Helps if you plug it in correctly. And when I hit enter, I get -0.75, which is the same as -3/4, right? So that does check out. This is my final answer, and it works. So we good. So once again, I'll always try to leave that up for a second just to give you some time. But main goal is, you go through your process, you make sure our main goal is that common denominator and getting kind of rid of some of the fractions to make our life easier. Then that makes the solving not too bad. But once you've solved it, actually always check it. So we'll see. I don't remember which one has an extraneous solution, but I know at some points there is one today. It's one of those things you have to check for, or else you just wouldn't know. So we'll see it when it pops up. All right. Oh, these kids are going to be the death of me. All right. So, sorry, I'm getting emails from people in there. It's going to drive me nuts. So, let's look at number 3. We'll kind of just see what's happening, solve it. It'll be tons of fun. Can't wait. So what's my equation? So it's 10 over x times x minus 2 plus 4 over x equals 5 over x minus 2. So that's my equation. As you're writing it down / kind of looking at it for the first time, our main goal is to find the common denominator of those fractions. I write it off to the side just to remind myself. You can do it in your head if you please. So I just make sure everything's represented. I'm going to need an x, right? There's an x here, there's an x here. So I need an x. I'm going to need an x minus 2. And then once I have those things, everything's represented. So I'm good. So my common denominator is just x parentheses x minus 2. So now I'm going to go back now that I know that that's my common denominator, and I'm going to multiply everything times that. So times x minus 2 times x minus 2. Same thing. Now we'll start to reduce. Don't forget that step as I did in the last one or 2 ago. And go from there. So the x minus 2 just cancels on this one. I'm just left with 10. Here the x's cancel, but I can distribute that 4 into the parentheses. So I would get plus 4x minus 8. And over here the x minus 2 cancels, and I would just get equals 5x. All right, so that's looking like a way better equation to solve. So this won't be that bad. What is that? 4x plus 2 equals 5x. If I move my x's on the same side, I would just get that x equals 2, right?
We got some issues.
Oh, yeah. What are they?
A lot of issues.
Oh, what are they?
We're going to get 0.
Exactly. That's what makes it an extraneous solution. Yay. So when you go back to check, know how we always wrote those domain restrictions, like x cannot equal this. This is kind of like we're just checking that. And sometimes you'll see in other situations it just doesn't work. But if we tried to plug 2 back in, it would give us a 0 in the denominator. That's not allowed. So that's going to be what an extraneous solution looks like in some of the problems. So once again, if I went to check it, because you're, maybe you're not paying attention, you're just like kind of doing your thing, got an answer, feeling good. When I go to plug that back in, I'm just going to write it out. Right here, I would get a 0 in the denominator, right? Because that would be 2 times 0. Once you see these zeros in the denominator, it's out. It doesn't work. So you would go back and you would, I always like kind of put an X through it and write extraneous. So what happens is now there's no answer, right? Like if that one doesn't work, there's nothing else. So your final answer is actually no solution. Because there's nothing that you could plug in that would make that correct. So just as a heads up, it's one of those things you're just kind of like, you're feeling good about it when you're solving it. It makes sense. You get to, but then when you plug it back in, since there are those zeros in the denominator, that's what our domain restrictions were telling us. We can't have these as answers. So it's kind of the same idea. And then once again, if that's an extraneous solution and there's nothing left, you would write no solution. Sometimes you might have 2 solutions, but one's extraneous, so the other one would just be if that makes sense. We'll look at that later, but just as a heads up. So you guys have been asking about that. It's really just check your answer. If it doesn't make sense, it's extraneous. So once again, I like to keep that up just in case you're copying. Once again, one thing I've learned from being at home is like you do not go at the same pace as when you're at school. Everything's a little slower at home. Boop. I'm just going to set up 4 as you guys are. I'm just giving you a minute to write that if you need it. All right, so let me show you number 4. Boop. Sorry, I'm just going to move this because it's annoying. All right, so here's number 4. Once again, we're only going up to 6. Woo. So we have a nice little rational equation. Once again, we have those nice fractions. We see the equal sign now. So we want to solve. In order to do that, we want to find the common denominator. In this case, to find the common denominator, I would have to factor that first denominator. So keep that as a reminder in the back of your brain there. Just like we did with adding and subtracting with finding common denominators, you have to factor first if you can. So I'm just going to rewrite this as x minus 3 over, that's a difference of 2 squares, x plus 5, x minus 5. And then we have plus 1 over x plus 5 equals 1 over x minus 5. So off to the side, I'm a labeler, so I'm going to label what my common denominator is. And it would be what? Just x plus 5, x minus 5. Because then everything's represented. We're good. Once you have that, you go back and multiply each individual term by that. So everything's getting multiplied by x plus 5, x minus 5. All right, it takes a second to write those bad boys. And then we're just kind of trying to reduce down the fractions, so then it's a little bit easier to solve for us. So in this case, those would both cancel out. You'd just be left with x minus 3. Okay. Here, the x plus 5 would cancel. And then if we have 1 times x minus 5, that's just going to give me x minus 5. So plus x minus 5. And then we have our equal sign. So just make sure you don't lose any of your signs along the way. Your x minus 5s cancel out. And then once again, I'm just multiplying by 1. So that would be equal to x plus 5. We always want to get it to a point where we can now solve it. And this shouldn't be that bad. I'm just going to combine like terms. That would give me 2x, not plus, 2x minus 8. Yeah, sorry. I don't know why I thought that was plus. Equals x plus 5. Let's get our x's on the same side. So we'll get x minus 8 equals 5. Sorry, I need to move it a little more. And then if I add 8 to both sides, x is going to equal 13. I'm not done until I've checked my answer. So what would I have? 13 minus 3 over 13 squared minus 25 plus 13 over 13 plus 5 equals, oh, excuse me, that's 1 over 13 plus 5. Equals 1 over 13 minus 5. Okay, that's a big mess. I usually just kind of like throw this side of my calculator. Just be careful when you're doing it that with parentheses and such. But if I have 13 minus 3, that's 10. 13 squared minus 25 is 144. So I have 10 over 144. And then that's, I'm going to add 1 over 18. Let's see what I get. I got 1/8. Once again, I let the calculator do most of the work because those are some pretty gross numbers. And then this side, 13 minus 5 is 8. 1/8 equals 1/8, so I'm good. So this is my final answer. And I know that because I checked it. So that would be number 4. I'm sorry, I X this out. Let me know if you need to have any questions along the way. I'll give you another few seconds for that in case you're copying it. All right, so just 2 more. Then we'll have a good idea. I can always stop for questions if you have them. Always let me know. Sorry, I keep feeling like I need to like change positions here. Number 5. All right, just 2 more. Delightful. So we got 3x over x squared minus 4 plus 2 over x plus 2 equals 1 over x plus 2. Okie dokie. So I need to find a common denominator. To do so, I do need to make sure my denominators are factored. So I'm just going to rewrite this as 3x over x plus 2x minus 2. A little difference of 2 squares there. And then the other ones kind of just stay the same. So I'm going to find my common denominator. And in this case, it would just be x plus 2, x minus 2. We're in a room. Okay. So just making sure that everything is represented. We're in good shape. So everything is going to get multiplied by that. So everything gets multiplied by x plus 2, x minus 2. I basically just put it with every single term. And watch the magic happen here. So in this case, that cancels. You're just left with 3x. In this case, the x plus 2's cancel. I can distribute that 2 into this set of parentheses. So you just kind of go over. And it is a positive. So that would be plus 2x minus 4. Oh, shniker wikers. I am so sorry, guys. This is a minus sign. I'm like, what am I doing? I knew it was a minus. What is wrong with me today? I'm sorry. I blatantly have a minus written right on my paper. That's why I write everything down. And that's why I still mess up. Sorry about that. Sorry, that was a negative. I knew something went wrong. So that would be minus 2x, and then 2 negatives would make a positive 4. Sorry, I just don't want to mess up my answer here. And then over here, my x plus 2's cancel, and then I'm just distributing a 1. So I would just be left with x minus 2. All right, that makes more sense. So that will leave me with x plus 4 equals x minus 2. And then like when we try to get our x's together, see how they're just going to cancel out? You've seen this happen before. You've seen this happen with just regular equations with variables on 2 sides. When your variables cancel and we're left with something like 4 equals negative 2, which is a statement that does not make sense, this would be a no solution problem. So before we saw a no solution because there was an extraneous, this is just no solution because nothing's going to work. So that can happen too. I just like to show you different situations that might pop up. But yeah, why not? It can happen with variables on both sides, and in this case it did. So there's nothing to check. This is just telling us, as you saw, there's nothing you can plug in that can make that equation true. So just as a heads up. And we just have one more problem. Oh my goodness gracious. All right. Last.
I have a question.
Oh yeah, go for it.
The other day on the homework, I got like all fractions. Was that supposed to be the answers? Because now going through these are all whole numbers.
Because I made these nice. I can put up the answers to that worksheet from the other day. I'll have to look at it though. I just don't remember. I made that like 2 weeks ago. So I will look at it and I can put the answers up for you and then we can always go over them later too. All I know is,
Thank you. I just want to make sure.
yeah, sometimes like it was a program we use and sometimes they just come out to gross answers. Like these ones I like specifically handpicked to make them like beautiful looking. So there is a very good chance you did get fractions the other day. But I will put that answer key up right after this. And then we can always go over them after vacay as well. All right. So last but not least, what do we got here? All right. I'm sorry. I'm always at weird angles. So the last one. I'm looking, I'm saying, well, I noticed that third fraction I'm going to have to factor it, right? So let me do that first. Anytime you're finding common denominators, you want everything factored. So it would be what? X plus 5, x minus 4. Okay. So my common denominator would just be x plus 5, x minus 4, because then everything would be represented. There's nothing else that we'd have to add in there. So that would be that. So now we're going to multiply everything by that. So I'm going to kind of add it in. Okay. Now let's see what happens. Here the x minus 4's cancel, and I get x times x plus 5, which I'm going to distribute into, and that will give me x squared plus 5x. Here the x plus 5 cancels. Just be careful once again because that's a minus 4, so I always kind of think of it as distributing negative 4 into this set of parentheses, and that's going to give me minus 4x plus 16. And then on this side, this cancels, that cancels, and you're just left with 36. Oh, so what's happening here? I can combine like terms, I guess. I get x squared plus x minus 16 equals 36. We haven't done a ton with quadratics this year. Last year, unfortunately, we had a little bit more time, obviously. Our next chapter is actually on quadratics. So we'll re-look at them. Even though you did see them last year, it's one of those things that always pops up. This one we can solve it. You guys can solve this. We're going to solve it by factoring. So for now, if you don't remember quadratic formula, that's okay. But we can solve by factoring. We're factoring champions here. But to solve by factoring, I do need to set it equal to 0. So I'm just going to move this 36 over here. And I'll be left with x squared plus x. What is wrong with me? This should be, I just keep writing the incorrect signs. I'm sorry, that was a plus 16. I'm subtracting 36. That would give me minus 20 equals 0. And then I'm saying I can factor this. So I know, we're good with factoring. X plus 4 plus 5, x minus 4 equals 0. So my two answers, if I set these both equal to 0, we've done this a million times because we've been doing this with our domain restrictions. Our answers would be negative 5 and 4. All right. Whew. So a little bit of a setup, factoring the denominators, finding the common denominator, multiplying everything by it, seeing what's left, solving it. In this case, it was a quadratic, so I'm not going to throw in any crazy quadratics at this point. We'll do that next chapter. But for now, you should be able to solve by factoring because we factored so gosh darn much. And that was our answers, but we're never done. We're not done until we check them. You're probably going to notice, if you think about what your domain restrictions would be, whether these make sense or not. But if you plug in negative 5, oh my God, I'm writing X. What is wrong with me today? minus 4 over -5 plus 5. Right here doesn't work, right? Because when you plug it into that denominator, and right here, -5 plus 5 is going to give you 0. Psh, it's out. Extraneous. If I plug in 4, I'm like going through, even if you're starting to do this in your head, that's okay. 4 minus 4 is going to give you 0. 0 is in the denominator is not going to work. Also extraneous. So in that case, we did have 2 solutions, but both of them aren't going to work. So if nothing works, your answer is no solution. Boop. Sorry, this thing is not my friend right now. Just the way it's set up. So with the extraneous solutions, once again, it just means to check it. And a lot of times it goes back to those domain restrictions. So if something came out to something that was restricted, if I could talk, that's when those extraneous solutions happen. So those were the problems I wanted to do. Reminder, today and yesterday, we're just kind of like getting an idea of what's happening. We're going to do a lot more when we get back. And I'll remember it's after a week and a half. So if you don't remember everything, that's okay. But at least we've now been exposed. I'll have to look. I'll have to go back and find that worksheet. Sorry, that was from like we plan ahead, and then it's like from far ago, which I shouldn't do anymore because we planned ahead and we had to redo all of our plans because of this full remote deal. So I'll have to go back and check those answers and kind of let you know. But then we can always go over stuff after vacation as well. But those are the main things I wanted to do with you today. Oh, and I'm gonna yawn. I'm sorry. Oh. It's been a long day. So, does anyone right now have any specific questions on the problems we just did? Okay. Hold on, I'm just gonna kind of get out of this bad boy. Escape. I'm going to exit out. I don't want to be here anymore. I don't want to present anymore.